Hello everyone, welcome to the last talk for today. And first of all, let me introduce myself. My name is Dmitry, and I am a security researcher in ERP Scan company. In ERP Scan company, I'm responsible for security assessment, penetration tests, and all research things related with different ERP systems. And especially, I'm focused on with SAP. And here is my colleague.
Hello, my name is Dmitry too, and I'm binary researcher and in ERP scan company.
Yeah, a lot of Dmitry's in ERP Scan. Okay. And as I said before, we both work in ERP Scan company. It is a security company with headquarters in Netherlands. Also, we have offices around the world. We found a lot of vulnerabilities in SAP and Oracle systems. Also, we made a lot of buzz about some of these findings. So, let's start. Actually, I have no slide with agenda, but I will try to explain what we want to present today. This talk is not about how important spend money and time on SAP security. I hope you know how it is important. It's very important. I will not tell you about best practices and how to set correct rights for your SAP users. This talk is just a little story about how we got yet another remote command execution vulnerability in SAP. And of course, we start with a slide about SAP. I hope some of you may know what is that, what is SAP. SAP is the biggest and most popular ERP system in the world. Many worldwide companies use this system. I have a collection of SAP advertised with some company names. Let's start with Discovery Channel. They use SAP. The next example is a manufacturer company like Fender, or automotive company like Porsche also have SAP installation. And of course, a lot of IT companies. Actually, really a lot of well-known companies have SAP. That's why we talk about SAP security, because if an hacker will get access to SAP, he will get access to the all critical business information. Okay, what do we want? We want a critical vulnerability in SAP system. How we can get it? Actually, a lot of ways exist. We can try to attack via web part of SAP, using typical web issues like cross-site scripting, CSRF, SQL injection, etc. Or we can use a specific vulnerabilities in ABAP or Java stack of SAP. We can try to attack via issues in Java servlets, transactions, and mistakes in ABAP code. Or we can use vulnerability in additional services of SAP like log viewer, software deployment manager, etc. But we decide to look at the binary level of SAP core application. One sec. Yeah. And we decided to start with probably most important binary service, SAP Dispatcher, and look at this plus work binary file. Binary file this plus work has a considerable size, around 51 megabytes. It's a pretty big file. And of course, as reverse engineers, we open this binary file using our favorite disassembler. In our case, it was IDA Pro, a very popular debugger and disassembler. As the result, we got a lot of assemblers code. IDADB has size around 143 megabytes. It's also quite a big file size. And of course, we tried to debug this process, but on this step, we got first problem. It was very difficult to debug network communication of this plus work. Why? Just because on the server side works not only one this plus work process. A lot of child processes also exist, and all these childs can handle the requests. It means we need to guess what child process is responsible for request, or we should try to attach our debugger to every child process. Let me show you. That's how the situation looks on the server side. As you can see, process SAP start created a lot of childs of this plus work process. Yeah. Also, you can see a lot of other processes like GWRD, it's a gateway, SAP gateway, ICMN, it's an internet communication manager, GStar process responsible for the Java stack of SAP, etc. For solving the problem of big count of this plus work, we decided to reduce the count of this plus work. It's logical. For that, we changed some SAP profile parameters related with dispatcher. On the slide, you can see the values of these profile parameters which was used in our test SAP system. Most important parameter is rd/configurable_wp_no. This parameter is responsible for the count of work processes. In our case, we set up it equals 0. And as a result, we got a picture like this. Only one this plus work process on the server. Actually, that's exactly what we need. But if you look closely on the processes list, you will see one thing. We lost GStar process. Where is the GStar? That is how process list looked before we implemented our profile parameters. Everything is okay, GStar worked fine. This is how process list looked after we implemented the profile parameters. Looks like GStar didn't start properly. But we don't care because our goal is this plus work. Forget about that. What is the goal of what is the goal of this little research? At the end of this research, we want to find vulnerabilities which allow us to get access to the SAP server, of course. Yes, we want remote command execution on the server side as a final goal. So, we spent some time for reverse engineering of this plus work, but we didn't find nothing interesting for us, which can help us to get remote command execution on the server side. Binary file is too big, we are too lazy for analyzing of every function. Probably hunting for remote command execution can take too much time. But maybe not. Maybe we give up too early. By the way, nevertheless, we decide to change our victim. Maybe we can choose another binary from SAP core, which will be not so big for quick research. We looked at the process list one more time. As you know, on the server side works a lot of different processes. GWRD, Gateway, ICMN, GStart, SAP Start, a lot of them. But no, we want something other. And we choose SAP Start SRE. Why? I will explain. SAP Start SRE, it is a part of well-known SAP service which is called SAP Management Console. This service allows to SAP administrator control SAP instance via HTTP protocol using different SOAP methods. For instance, administrator can start or stop SAP, read log files, change SAP profile parameters, get process list, and etc. In the modern version of Management Console, almost all these SOAP methods require authentication. Administrator should provide operating system level username and password. Nevertheless, as I said, this area is well known. That's why even in the Metasploit framework, you can find a lot of models for SAP Management Console. But for exploitation of these models, you need to provide a username and password. So let's put our binary SAP start SRE file in disassembler and look at that. SAP start SRE has a 15 megabytes of size, use ports 50013, which can be accessible via HTTP requests. Interesting thing, this port is also available when main SAP services is switched off. Also, as I said, SAP Management Console has a lot of interesting swap methods. One of them is OS execute method, which allow to, guess what? Right. This method allows to execute operating system level command. That's exactly what we need for command execution. But we should solve one little problem. We should to bypass authentication. And at this step, I want to give a word to my colleague Dmitry.
So look and disassemble and try to understand how authentication works. Substart SRV, get HTTP request, extract username, password, and check with username and password. Because it shall be OS level user and password servers, check it using OS information. But we found one interesting thing. During with understanding, we found a function which has interesting name. It's called it's trusted internal connect, which called during authentication checks. Looks like exists some internal services which also require authentication on substat SRV. Maybe for what function SAP use another type of authentication. And yes, inside this function we found hard-coded username. What interesting. This username looks pretty interesting and not look like normal username. What's important, it's not operational system real username. It's mean this function, is Trust Internet Connect, can authenticate SAP Management Console without having a level user. And if we back to this user and try to Google it, we can find information about first username. Is documented username, which can be used for getting temporary login tickets. But we don't find any information about another one. And because now we have way to execute command on operation system level, we also execute SOAP method, and we have login name for that. We need only the password. Maybe password also hard-coded. No, of course no. In this case, it's really easy. So let's try to understand how this function works and where we can get password for these hard-coded users. We found few interesting functions inside. It's called JSF Open SHM and JSF Close SHM. All these functions have common part SHM, and we have questions. What is SHM? SHM means shared memory. It's part of memory which allows two or more processes share the data. For example, one process can write something with shared memory and another process can read this data. How you can see, it's IPC mechanism. Okay, but back to our functions. Try to understand what exactly we do. Okay, JSF Open SHM looks like this function Open SHM, and JSF Close SHM looks like this function just Close SHM. Okay, but what do this function JSF check SHM key string? Looks like this function checks some key. So now we should answer a few questions. What is the key? Maybe with key we pass hard-coded for users. And is this key static? And if it's static, can we guess this key? Is this not static? And can we brute this key? Let's answer on these questions. Yes. With checking key is a password for authentication on substart SRV. And is this key static? No. Key is not static. Key generated randomly and has len equal 36 bytes. Can you guess this key? No, because it's pretty long. And we can't brute force it because it's really pretty random. So looks like this function is pretty secure and we can get password for hard-coded usernames. But we didn't give up. And we think, what if we try to debug a little? We wrote small Python script which tried to execute OS execute method using hard-coded username and our key. In this case, it's our key, what called blah, blah, blah. And after that, we attach to our target servers, substart SRV, using our debugger and trying to understand what is key expected by Management Console. Yep, demo time. Okay. First, we log in our stand and find Pete, our target, substart SRV. Okay, we found Pete. After we attach to our target. And how you see, we set breakpoint to function JSF check shmk string. Okay, we set one breakpoint. We run our script and wait when this breakpoint triggered. Okay, we insert this function and now we're trying to find what key this service expect. Okay, we set breakpoint and function to compare two memory regions. And now, read them. Okay, it's our key, x blah 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 x, and trying to see shmk. And as you can see, it's not looks like random. Yeah. Okay. And it's look like very predictable key. It's a very good thing for us because probably exists some situation when this random key is not random. So we have way to execute command on operational system level of SAP. We have username and probably we have a password for this hard-coded name. So our next goal is understand why this key is XAAX. For what we shouldn't understand more deeply how this function, JSF check shmk string, it works. In this slide, you can see how this function works. It reads out binary key from shared memory, and after some modification, convert this key to readable string format. And after that, add chars x to the end and of begin of the key. After that function, check key with user input, and if everything is okay, return positive result. Back to our key value, why it's equal XAAX? Its answer is pretty simple. Just because shared memory has 0 values, looks like some processes did write raw value in K and SHM, and what why substat.hcv convert these 0 values into XAAX. It means some shared memory problems occur. We spent some time to understanding why it's happened, or what process shouldn't put RAV K in shared memory, and we should find who is responsible for that. Okay. But do you remember we changed some profile parameters for reducing the count of these plus work processes. And as a result, we got only one this plus work processes and just start process, which not start. Okay, we decided to change back all our profile modifications. We comment always parameters and restart system. What we got after restart? Of course, JStart successfully started, and password for hard-coded usernames become random again. And password XAX not working anymore. So it means we can execute command on server side via SOA request if we can authenticate using hard-coded username and our magic key XAX. But for that, we should change some parameters in SAP system instance. Or we can try to do another way. What if we need to just stop JStart process? For checking this idea, we wrote another Python script which tried in cycle execute command and server side using SOAP method as execute and using hard-coded usernames in our magic key XAAX for authentication. And afterward, we will try to kill the start process, now only local for our experiment. We log in our SAP SRV server and execute kill all command. And if everything right, our script which tried to execute command via SOAP can do it. And because password for hard-coded username was XAX, but nothing. This method not work. Okay, we didn't give up. What if not only one JStart process responsible for putting RAV K value in shared memory? What processes also can be responsible for that? Maybe ACM, Internet Communication Manager? And you may ask question why we decide to choose ICM process. And we can answer only it's our intuition. So, new plan is run our script which try to execute SOAP method, request using hard-coded username in our magic key, and we'll try to kill ICM and JStart process locally on machine using kill all command. Okay. Okay, let's connect our stand. Now connecting to our server, and we run a notcard. run our Python script, what in cycle try to execute SOAP method, also execute, what call it also execute. And now, in server side, we kill JStart and ICM man. Okay, looks like all the work because we get reverse connect back shell. Okay, how you see, we SAP administrator on this system. It's very cool, but for remote attack, we should kill JStart and ICM remotely. For what we should find DOS for JStart and DOS for ICM. And we start with JStart. JStart process is responsible for Java stack of SAP. And yes, we found DOS for JStart after 3 days of research. It's possible race condition. And as a result, attacker can send few special requests on JStart port, which will trigger the vuln, and JStart process will be stopped. What interesting, JStart process restart after the crash. So JStart was easy target. Okay, on this slide you can see part of request, which allow you to trigger DOS of JStart, and also can you see crash log from debug session. Okay, now we need only one more step for triggering a remote command execution. We need DOS for ICM. Yeah, ICM. Okay, what is the ICM? ICM is Internet Communication Manager, is one of core components of SAP, which is responsible for many things. Most of these things available via HTTP. So we need DOS vulnerability in ICM servers. On this slide, you can see some information about binary file. It has size almost about 6 megabytes. And because it's one of core components of SAP, which available via HTTP, probably it's heavily audited. First of all, we try to find some information about those vulnerability in ICM of public sources. Last bug, DOS bug, was found about 2 years ago via no vectors without any details. Looks like it'll be not so easy as we think. But after 35 days and some weekends, we found issue which allow us to trigger DOS attack. On the slide, you can see a part of requests which allow attacker to crash ICM process. And again, what interesting process ICM restart after the crash. It's very useful for our future attack because in this case we can execute our attack without serious things for business processes of companies. And again, race condition issue in ICM allow us to trigger it with DOS bug. So now we have all pieces of puzzle for our remote command execution. Finally, plan is run a Python script which will be tried in cycle authenticate on SAP Management Console services using hard-coded username and our magic password, and trying to execute SOAP method, also execute, which run reverse shell payload on a SAP server. After that, we will run those exploits, which will crash ICM and restart processes. And if everything is okay, we get our Rails connect back shell. Okay. Okay. And first part of screen, we run netcard. And second, we run script that try to DOS ICM. And third, we run script that DOS JStart. Now we run our Python script. Want to try to send a SOAP request with our magic key. But in this time, we get response from server. Say what we not authorize it. And now we shouldn't wait a little. And it's all. We get connection to now our netcat port, and we get our remote control, remote command execution. And we SAP admin on this system. Okay, finally. On the slide, you can see SAP nodes, which close this box. And
Yeah.
yep.
A few words about conclusion.
Yeah.
At the conclusion, we have few. For the security researchers, don't give up. If you can't exploit vulnerability using one issue, try to find another way to trigger it. For SAP administrators, even no so critical issue like a denial of service or not exploitable on the first look hard-coded credentials can be very dangerous, because in modern world, attacks contain from chain of different small issues. That's why it's very important to apply security nodes even for the small bugs. And for everyone, of course, have fun. And so I think that's all from our side. Thank you very much.